Hello YouTube, today we're going to be doing some practice problems with some double integration. Now in the previous videos, notice how it was only like dy dx and there was no integrand there. Actually the integrand was a constant, I should say it was a constant of 1. But now this difference with these, now that we have a function in the integrand, pretty much the area here is just a region over a 3D surface. But right now we're only going to be practicing switching the limits of integration once again, but I do want to emphasize that we are doing 3D objects now rather than just area. So this will be a volume. Because we have an integrand. So I drew out the graphs there for you, and we're going to be finding that area of that orangish region there. So also you want to label the points, set up your double integral, same thing, but now we're going to switch to dx dy. Now to find the points, you're going to want to start on the outside, so y equals. So y equals 0 to pi, because we're going to go up, 0 to pi, but make sure we'll label those coordinates as well. But yeah, 0 to pi. So we start at y equals 0, so the x-axis, and we're going to pi. That's the y direction. But now we want to do the same thing for x. So what would be that limit of integration? Well, since we're doing a rectangle that's horizontal, we're going to do right minus left. So the rightmost side would be y equals x, or x equals y. And we're going to subtract that from the 0. So pretty much, if you want to evaluate this, I'm not going to show the steps too much, but this is how you would set up for your evaluating the integral, but I just want to show you the practice part. But again, I want to emphasize that this is, we're integrating with horizontal rectangles. Okay, so now we'll move on to the next slide here. Alright, so same thing, we're going to be integrating a three-dimensional object and finding the volume, but right now we're just going to be practicing switching the limits of integration, and we're going to be doing it over a region R, which is an area. So you're going to want to draw out those graphs there, and notice how we have I guess half of a circle here, upper half, and drew out the boundaries there, 0, well, now we're going to switch the limits of integration, so everything stays the same except we're going to have dx dy at the end. So now we need to find the limits of integration. So to do that, look at that red rectangle there, and we're going to figure out our bounds. So what would be our y bounds? Well, we're going to be going from y equals 0 to y equals 4, which is that orange part at the top there. That's how high we're going to go. We're going to start at 0 and go to 4. So that's the y equals 4 line, that's the y equals 0 line, then you plug in those limits of integration. Now how far are we going to go in terms of x? What's changing? Well, we have, we're going to do right minus left, which is the green, minus the light purple, which is also the y-axis. So, but we have to write it with respect to x, so you have to actually manipulate the equation. Yeah, but first, so there's the left part, so 0. But we also have to manipulate it with respect to x, so we have x equals the square root of 4 minus y instead. And then we have that up there, and that's how the limits switch. If you wanted to solve it, well, we won't do that, but just want to move on with the drawing the pictures and switching limits of integration for good practice. So we'll move on to the next slide. Okay, so now we have another problem here. So we want to draw out the graph. Make sure you label the axes. I always set up the bounds first, like the lines are always the easiest to set up. So we have y equals 1, x equals 3, and x equals 0. But now we want to do cubed root of x, the square root of x over 3. So we know that's going to look like the square root of x, but so you know it's going to look like that. So there's the equation there. And we're going to find that area bounded between those regions. So that's what we're looking for. But we also want to find what the coordinates of the points are, and to do that you simply set the two equations of the lines equal to each other and solve, and you should get 3, 1 as the coordinate, and the other ones should be pretty obvious. So now we want to set up our double integral. Same thing, the setup now, but we're switching the limits, or we're switching the integration here to dx dy. So now we want to switch the limits of integration in order to do that, and so I kind of already went ahead here, but so we have y equals. How high are we going? Well, we're starting at y equals 0, which is the x-axis, and going to the height of 1, of y equals 1. Now what about the x portion? Well, we're going to do right minus left, which would be the green the function that's the green line there, minus left, which would be the y-axis, or x equals 0. But we have to make sure we convert that function with respect to x. So you have to set it with respect to x here. And then you plug in the equation, and that would be your answer. So that's pretty much how you have switched those limits of integration there for you. But remember, notice how we were doing other functions. Originally we had like a double integral and then just nothing really, and it said dy dx or something. Well, that nothing's actually a number 1. But now that we have a function in the integrand, that means we are now dealing with volume. So just to keep that in mind in terms of the difference, and this is just the region it's being integrated over. So I hope that helped in terms of practicing, and keep up the good work.